Betelgeuse, the star positioned on the shoulder of Orion's mighty warrior, has been displaying unusual patterns of activity, sparking excitement over a rare, potentially once-in-a-lifetime cosmic event. Some experts propose that this increase in brightness might indicate the star's approach toward a supernova. However, the precise timing of this event remains unclear. Experts suggest it could happen in the not-too-distant future. Let's delve into the present state of this star. If you wish to stay updated on 32 seconds, the latest news from the universe, including all its mysteries, consider subscribing to our channel, liking this video, and activating the notification bell. Even if you haven't personally encountered it by name, you've likely seen the dazzling Betelgeuse, a brilliant red star that gleams in the constellation of Orion. Betelgeuse is a truly spectacular sight. Currently, Betelgeuse is an extremely massive star. If we were to place it in the center of our solar system, its surface would extend beyond the orbit of Mars. This enormous 1 minute and 6 seconds and easily visible star continues to captivate observers because it is relatively close to our galaxy. Betelgeuse undergoes noticeable changes, fluctuating in brightness. This is typical of semi-regular variable stars, where the brightness may shift dramatically as they approach their final collapse into a supernova explosion. Recently, Betelgeuse has been even more intriguing due to sudden and unexpected changes in its luminosity, a phenomenon that remains perplexing. Though its strange behavior, 1 minute and 37 seconds, was already unusual, it became even more captivating due to the great dimming event that took place between 2019 and 2020. During this event, the closest red supergiant star to Earth shone twice as brightly, lighting up the early evening sky in the southern hemisphere. This abnormal behavior from one of the brightest stars in the sky has granted scientists an extraordinary chance to observe Betelgeuse's rapid transition from brightness to dimness. In more recent times, Betelgeuse has exhibited increases in its brightness of over 50%. 2 minutes and 11 seconds. On May 20, 2023, a Twitter account named Betelbot, dedicated to tracking the star, reported a remarkable 142% surge in brightness, citing information from the American Variable Star Observing Association. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse is now ranked as the 7th brightest star in the night sky, moving up 3 positions from its usual spot at 10th. In the southern hemisphere, it's quite easy to spot Betelgeuse glowing at dusk, and even in 2 minutes and 43 seconds. The northern hemisphere, it can be seen as the nights grow longer. A researcher from Swinburne University in Australia emphasizes that Betelgeuse offers one of the most fascinating opportunities for scientists, observing the final stages of a massive star's life in more detail than ever before. This allows astronomers to gain significant insights into what happens to red giant stars just before they explode as supernovae. There is speculation that Betelgeuse might become so luminous that it could even 3 minutes and 11 seconds shine during the day, casting shadows at night. This remarkable behavior has captured the fascination of both professional and amateur astronomers alike. Eventually, Betelgeuse will meet its end in a spectacular supernova explosion. From our location, about 650 light-years away, we will have the rare opportunity to witness this cosmic phenomenon in real time. Heidi Morris, a scientist at Los Alamos National Laboratory and president of a local astronomy club, shares that people have long been captivated by Betelgeuse. 3 minutes and 46 seconds. Closely monitoring its changing brightness. Astronomers have known for a long time that Betelgeuse experiences cycles of intense brightness followed by periods of fading. This cyclical pattern was observed even by ancient Australian Aboriginal and Greek cultures. Typically, Betelgeuse's brightness cycle spans about 400 days, but recently it has been fluctuating much faster, around every 130 days. Andrea Dupree, who has been studying the star, points out that this accelerated behavior began in 2019 after 4 minutes and 18 seconds. Betelgeuse forcefully expelled parts of its outer atmosphere. These brightness fluctuations are highly atypical for Betelgeuse, raising the question, does this suggest that the star is on the verge of exploding into a supernova? According to a study co-authored by Dupree and scientists from Harvard and the University of California, Berkeley, it is predicted that it could take 5 to 10 more years for Betelgeuse to return to its normal cycle. The paper states that Betelgeuse has not been the same since 4 minutes and 46 seconds. The Great Dimming Event and has exhibited distinct changes in both its luminosity and radial velocity. Despite the unusual behavior, Betelgeuse still has a long journey before it eventually undergoes its supernova transformation. As a red giant, Betelgeuse goes through a series of fusion processes that involve elements such as helium, carbon, oxygen, silicon, and iron. The immense pressure in the core of the star allows helium to fuse into carbon, after which the star continues fusing carbon and helium to form oxygen, and so 5 minutes and 18 seconds on, producing heavier elements like iron and silicon. These fusion reactions will eventually cause Betelgeuse to collapse under its immense gravity, which could lead to the formation of a black hole or neutron star. Current observations of the chemical makeup of Betelgeuse's atmosphere indicate that it is in the early stages of this fusion process, specifically fusing helium into carbon in its core. A rapidly evolving star, Betelgeuse has led an intense, fast-paced life. As it nears the end of 5 minutes and 48 seconds, its accelerated evolution, it will eventually exhaust its fuel, and the core will collapse, leading to an explosion so massive it could outshine entire galaxies. While the occurrence of a supernova is inevitable, the exact timing remains a subject of debate. Despite much speculation about when Betelgeuse might explode, there remains uncertainty. Peter Brewer, an astronomy professor at the University of Portsmouth who specializes in supernovae, has written a book on the topic. He highlights the fact that we currently, 6 minutes and 22 seconds, have no reliable way to predict when stars will explode. Therefore, there's no clear indication of when Betelgeuse will meet its explosive end. This uncertainty is understandable, as, throughout human history, there have been very few supernovae observed in sufficient detail. Given this lack of certainty, we still don't know if any of us will live to witness the awe-inspiring explosion of Betelgeuse. In the grand scheme of stellar evolution, the life cycle of stars like Betelgeuse offers an exceptional opportunity for 6 minutes and 53 seconds. Astronomers to explore the very final stages of a star's existence. Understanding these stages is crucial, as it brings us closer to comprehending the complex processes that govern the death of massive stars. Betelgeuse, by virtue of its size and proximity to Earth, serves as an unprecedented living laboratory for such research. Stars like Betelgeuse begin their life in a relatively calm and steady state, fusing hydrogen into helium in their cores. This process continues for millions of years, but as the fuel runs out, the star, 7 minutes and 27 seconds, undergoes significant changes. For red giants like Betelgeuse, this involves the expansion of the outer layers, and the star enters an unstable phase where it begins to pulsate. The rest follows a similar structure. These pulsations, caused by the constant push and pull of gravity and radiation, make Betelgeuse an unpredictable spectacle. The changes we are witnessing in recent years could be a prelude to its final moments, though the exact timeline remains uncertain. Scientists are particularly interested in whether Betelgeuse's increased brightness and irregular pulsations are signs that it is nearing the end of its life. If the star does go supernova within our lifetime, the explosion will be visible even during the daytime, outshining the full moon for weeks or even months. 8 minutes and 28 seconds. The supernova would release an immense amount of energy, creating an expanding cloud of gas and dust. This material will eventually mix with the interstellar medium, seeding the galaxy with elements necessary for forming new stars, planets, and even life itself. Once Betelgeuse explodes, what remains of the core could collapse into either a neutron star or, if massive enough, a black hole. A neutron star would be an incredibly dense object, only a few kilometers across but with a mass greater than the Sun. If Betelgeuse's core is heavy enough, gravity may overwhelm even the ability of neutrons to resist collapse, forming a black hole, a region of space where gravity is so intense that nothing, not even light, can escape. 9 minutes. While we wait for this spectacular event, astronomers continue to monitor Betelgeuse with some of the most advanced telescopes on Earth and in space. Observatories like the Hubble Space Telescope and the Very Large Telescope in Chile have provided detailed images of the star's surface, showing massive convective cells, giant bubbles of hot plasma rising and falling. These cells may be responsible for some of the fluctuations in brightness. Additionally, the James Webb Space Telescope, JWST, is expected to provide even more insights into the behavior of Betelgeuse in the coming years. Its infrared capabilities allow astronomers to see through the dust that surrounds the star, giving them a clearer view of the processes happening in its outer layers. 9 minutes and 34 seconds. Despite the uncertainty of when Betelgeuse will go supernova, its evolution offers a rare and valuable window into the life cycle of massive stars. The more we learn from Betelgeuse, the better we can understand the fate of other red supergiants, including those that may one day explode in galaxies far beyond our own. For now, we continue to watch and wait. Will Betelgeuse surprise us in the coming years, or will it quietly continue its slow, unpredictable pulsations for centuries to come? Only time will tell. But one thing is certain: when the explosion finally happens, it will be one of the most extraordinary celestial events humanity has ever witnessed. Until then, the mystery of Betelgeuse continues, a reminder of the vast, dynamic, and ever-changing nature of the universe. As astronomers keep their eyes on Betelgeuse, new theories emerge about what might be happening within the star. Some scientists suggest that the recent brightening could be a sign that Betelgeuse is undergoing a complex internal restructuring. The star might be experiencing convective surges, waves of energy and matter moving within its core, that temporarily increase its brightness before it eventually fades again. Others speculate that Betelgeuse may have already ejected a significant portion of its outer layers, forming a massive cloud of dust and gas. This could explain the great dimming event of 2019 to 2020, where the star's light dropped dramatically before recovering. If this is the case, then Betelgeuse may continue to experience such fluctuations, with its brightness rising and falling unpredictably in the years to come. 10 minutes and 36 seconds. Observatories worldwide remain on high alert, ready to capture any signs of the star's impending collapse. If Betelgeuse were to go supernova tomorrow, we would see the explosion instantly. Even though the event would have actually occurred 650 years ago, the time it takes light to travel from a star to Earth. The first signs of the explosion would likely come in the form of a burst of neutrinos, ghostly particles that can pass through nearly anything, even an entire planet. Neutrino detectors buried deep underground, such as Japan's Super Kamiokande and the Ice Cube Observatory in Antarctica, are poised to detect this burst. Within minutes, telescopes across the world would turn toward Orion to witness the most spectacular event in recent history. 11 minutes and 8 seconds. As the explosion unfolds, a brilliant light would emerge from Betelgeuse, growing rapidly in intensity. 4 weeks, it would dominate the night sky, casting shadows even in the dead of night. During the peak of the explosion, Betelgeuse might even be visible in broad daylight, appearing as a bright point rivaling Venus or even the full moon. But beyond the spectacle, scientists would be gathering critical data. Supernovae are responsible for creating the heavy elements found throughout the universe, including those essential for life. Observing Betelgeuse's explosion in real time would provide an unprecedented opportunity to study how these elements are forged and dispersed into space. 11 minutes and 40 seconds. As the initial explosion settles, Betelgeuse's remnants would begin to take shape. If the core collapses into a neutron star, it would be an unimaginably dense object, spinning rapidly and emitting pulses of radiation, a pulsar that could be observed for millions of years. If the collapse is more extreme, Betelgeuse could instead become a black hole, forever disappearing into the abyss. Whatever the outcome, the death of Betelgeuse would not be an end, but a beginning. The elements scattered by its explosion would one day contribute to the formation of new stars, planets, and possibly even life. Just as the iron in our blood and the calcium in our bones once came from ancient supernovae, so too would future generations of cosmic objects carry the legacy of Betelgeuse. 12 minutes and 10 seconds. Until that day comes, Betelgeuse remains a living laboratory, an astronomical time bomb ticking away in the vastness of space. Whether its final moment arrives in our lifetime or many generations from now, its story is one of wonder, mystery, and the ever-evolving nature of the cosmos. For now, we wait, gazing up at Orion's shoulder, knowing that one day, perhaps soon, perhaps centuries from now, the heavens will put on a show unlike any seen before. The mystery of Betelgeuse continues.